Good evening. Hello and welcome to Science Never Stops with the U.S. Space and Rocket Center. My name is David Weigel and I'm the Planetarium Director at the Intuitive Planetarium. And tonight we are going to be talking all about Saturn. A little bit about the Cassini spacecraft, a little bit about its moons, and certainly about its spectacular rings. So a very fun lineup this evening. And for those of you just joining us now, hello, welcome. This is Science Never Stops. And as we start to have some people tune in, typically we ask where you're watching from, and so I would be thrilled if you'd let me know where you're tuning in from this evening. But also, I realize that this is typically around dinner time. That's usually my family eats dinner when they're chiming in for these weekly. So I guess if you're eating dinner, let me know, and let me know what you're having too. I'm quite hungry. It's been a long week for me. So hello to Natalie and your 9-year-old space lover, Angelina from Texas. Welcome back. Thanks for joining us. All right, so as we continue on this spectacular pan and get things rolling here, this nice pan across Saturn, it's important to point out that Saturn is arguably the most, or at least close to the most beautiful planet in the solar system because of these spectacular rings, and we'll get more into that in a moment. But I do just want to highlight that if Saturn didn't have its rings, it would look a little bit awkward, to say the least. So if you want to picture what you think that might be looking like, then I can help you out a bit. And it's something to this effect, and a lot less beautiful, right? So really the rings add substantial excitement to this world, and or at least substantial beauty. So we'll bring them back and keep them for the rest of the presentation, because that's certainly a very hallmark sort of thing in here. All right, so a few people also chiming in. Larry from the Chicago area, Michael and Joe and Julie from Shreveport, Dean from Birmingham, Dina from Florida, hello, good to see you. And our first question is, how many moons does Saturn have? And her favorite is Titan. And the follow-up question is, could life be supported there? So that's getting a little bit ahead of ourselves. Hello to Christina and Brendan as well. It's getting a little bit ahead of ourselves, but let's take a look at moons. That's maybe a good place for us to start. I'm going to zoom away here. We are using Digistar 6, which is the planetarium software we use typically at the Space and Rocket Center, and I'll be flying this using an Xbox controller as per usual, and also running through a control panel I've set up as well, which we would usually run through an iPad, but I didn't get to bring all the fancy toys home in our haste. Okay, so as we're backing away, let's take a quick guess. How many moons does Saturn have? Is it 1? Is it 2? 1 like the Earth, 2 like Mars, 3 like nowhere in the solar system? Is it more? How about a lot? Saturn has 82 moons. And this actually makes it the most moon-populated location in the solar system. So Saturn is actually the king of moons in our solar system. And this is a relatively recent scenario. This is something that was recently announced as of maybe October of this past year. And I'm going to apologize in advance. If I'm struggling a little bit, I had our second child was born a couple days ago, which is super exciting, and I'm exhausted. She didn't sleep last night at all. So if I say something that makes absolutely no sense, please do call me out on it, and I'll see what I can do. So while there are at least 12 moons, there are actually 82 moons, and these are a relatively recent announcement. 20 of these or so are a relatively recent announcement. And it's not that they were newly discovered. We don't have any active satellites that are orbiting Saturn or its moons. We don't have any really nice in situ measurements that are going on, aside from general ground-based and the occasional Hubble observations that are happening of Saturn at this point. And you can see this sort of mess of moon orbits as we sort of zoom around here. But what's happening is that when we look to older data, we're able to very painstakingly try to decide, what is a moon? And I guess that raises another question of what is a moon? How do you say that a moon is a moon? How do you say that a moon is an object that is nearby a world and something that's just passing by is just passing by? Right? And it may seem a little bit obvious, but it's a little bit less so. And if you joined us last week for our conversation about Pluto and what makes a planet, the conversation of what makes a moon is also a very vague thing, and even a little bit more up for debate than a planet. So in order to be a moon, you have to be not round like a planet, not spherical like a planet. You simply have to be an object that is in stable orbit around another object. So that would mean if you have a planet that's large, like Saturn, Saturn's the second largest planet in our solar system. If you have a planet that's large and you have something that is stably orbiting around it, that is a moon. Okay, so what does that mean? And could a moon have a moon? To answer the second thing first, perhaps yes. We haven't observed that anywhere in our solar system or anywhere else, but certainly could be. And then that raises the further question of what do you call that? A moon? A noon? Also up for debate, and we're completely getting off topic. So the question is, how do you determine if something is in stable orbit? What does that mean? Does that mean you need to have something that's in orbit for a year, 5 years, 10 years? There isn't a set answer, but basically it's a long time. You're looking at thousands of years, and it's a little bit difficult for us to determine how stable an orbit is because some of these things are really, really tiny. So getting back to, I think it was Angelina's question from earlier, talking about Titan. Titan is the largest moon of Saturn. It's the second largest moon in the solar system, and it's actually bigger than Mercury by about 1%. It's about 1% bigger in diameter than Mercury. So it's actually bigger than a planet. Very large moon, right? On the flip side, many of these little moons of Saturn are very, very tiny. Very, very, very tiny, like single-digit miles across, even maybe like 2-3 miles across. And so how do you take good imagery of those things from very far away? You don't really. And it's rather difficult to calculate out their orbits and do so for a long time because they can be influenced by lots of things. So it's very hard to say whether they're in stable orbit or not. So with all of that said, how do you determine if a moon is a moon? You have to do a lot of complex modeling and take into account lots of different gravitational things, and eventually you can say, yeah, this thing is pretty stable or not. And so while the observations of these moons were made in 2006, 2007, 2008, back in October of last year, they determined, hey, we've got about 20 candidates that are quite stable, and we can count them as moons as well. So that was a really long way to say Saturn has a lot of moons, 82, and 20 of them are very new. Cool. All right. So some people said, congratulations. Thank you so much. I'm very excited and very sleepy. So Jamal says, does that mean that planets are star moons? I guess you could make that argument, perhaps. That's not a terrible argument to make, and I'm too tired to refute you either way. Okay, so I'm going to get back into this. We're going to bring these moon orbits off, and right now we're looking at the sort of upper atmosphere of Saturn, and it's important to point out that Saturn is a gas giant, which is very, very different from Mars, which we explored earlier. It's different from the Earth. It's different from Pluto. It's a gas giant. So what this means is that if you went there, you couldn't stand on it. There's no surface to stand on. It is mostly hydrogen, a little bit of helium, and trace other gases. So it would be as if you were trying to stand on clouds if you went there, and obviously you can't do that. And so you'd sink through the clouds if you tried to sort of stand on them. And as you sunk through the clouds, the gravitational pressure, the atmospheric pressure would increase tremendously, and you would get crushed very, very quickly. So you wouldn't just fall until you hit the center or sort of, fell through it and then kind of oscillated back and forth. No, you would get crushed well before then. And then your remains, I suppose, would do that. We have sent probes into the atmosphere of Jupiter, and they got crushed incredibly quickly, and that doesn't work so well. The Cassini spacecraft actually crashed into Saturn, more on that in a bit, and that didn't end well for it either, so though it wasn't designed to do that. Okay, so we're zooming in on this, and this is what we call the polar hexagon, and this is a really strange thing. This quite literally is a hexagonal storm, sort of a polar vortex, polar jet stream that exists here, and each of these sides of the hexagon is about 8,600 miles across, or long, I suppose. That's bigger than the Earth. So this is maybe 22,000 miles across, a substantial thing. It's a very strange, unique feature in the solar system. It is something that we've been able to reproduce with numerical models back on the Earth, with some sort of weird fluid shear, fluid dynamics, and is maybe the result of some sort of standing waves in the atmosphere. Very poorly understood, very funky, very pretty. But that's something that's quite stable and persists there. At the South Pole, we don't have it in this imagery, but there is a really nice South Polar Vortex, which you can look up on your own later if you so desire. So if you're just joining us, at the beginning we were talking about Saturn without rings would be less than exciting. Turning them back off, you can see it almost looks sort of like Venus, though it's nothing like Venus, and we'll keep those on. I do want to point out that these rings are, while very beautiful, while they look a lot like Mario Kart Rainbow Road style sort of things, perhaps, you certainly couldn't drive on them like that, unfortunately, because they are actually made up of ice particles for the most part. So as we cruise into them and get closer and closer and closer, you'll notice two things. First off, they're very, very thin. You can sort of see through them in here. And secondly, if we sort of zoom down a bit, you'll see that they are indeed made of ices, mostly water ice, sprinkled with some sort of tholin impurities, kind of like what we talked about at Pluto, where we have these complex hydrocarbons recombined into this sort of reddish sticky snow, but very, very thin. We're only looking at about 30 feet thick on average, so very, very, very thin. So I guess a follow-up question could be, what would happen if you flew through these as an astronaut on an EVA, for example? Would that be a bad idea? And yes, it would be a bad idea, but it wouldn't be the worst idea you could have. These ices are quite soft, and while they're more densely spaced than, or more sort of densely compact than the asteroid belt, they still wouldn't really puncture your suit, most likely. Don't hold me to that, but probably not. And again, pretty thin, so they'd probably clump to you, and that could be a little bit difficult, but shouldn't be the end of the world, hopefully, or your life, maybe. Let's see. Looking back at the comments and questions, there's a question from Courtney that says, so planets are made of moons if planets are star moons? And not really, no. Though all of these things are sort of formed typically around the same time with that star. Shortly after the star is born, the rest, planets and moons and that sort of thing forms. But then while this is all sort of from the same building blocks, planets are not moons that clump together. Dan says, how close can we get to the center before being crushed by gravity? That is a great question that we could probably do some math on that I don't know off the top of my head. And Colin brings up, congratulations on wearing a different shirt despite having a baby. Thank you so much. This one is also clean. Okay, so let's zoom in. And the reason that we know, taking a quick segue here, the reason that we know so much about Saturn and the reason that we have these spectacular views at Saturn is because of a spacecraft called Cassini. So what I want to draw for you is a quick look at where the Cassini spacecraft flew over the, say, 13 years or so of its lifetime. So we can see these right in here. And again, what you're looking at is all of the Cassini spacecraft's orbits over about 13 years. And let me make sure that, there we go, I think we've got them all on now. This is 13 years of orbits. It orbited around Saturn 294 times. And this is something that was only supposed to last maybe 4 years or so and got continuously extended because of the benefit of the science that was being done, but also great project management and fuel management as well. So there was only fuel supposedly to last maybe 6 to 8 years, and through very, very careful astrodynamics, using moons, different moons as sort of gravitational slingshots, the Cassini mission was able to be extended quite a long time until September of 2017, when it finished its grand finale orbits. Those are the lime green ones in there. And you'll notice that they actually seem to be going between Saturn and its rings. And it did this about 22 times. It orbited between Saturn and its rings, getting closer and closer each time, and eventually crashing into the upper atmosphere intentionally so that it wouldn't contaminate any of the moons in the Saturnian system. And this is of interest because Saturn's moons are very unique. They're quite varied as well in type, and they also have some very interesting potential for habitability. So I'd like to jump into that a bit here in a moment. But I also want to show you one last thing that has to do with the rings. I did show you that these rings are very, very thin, but they do extend quite far away, out to about 175,000 miles away from the upper atmosphere. So quite far away. And click the wrong screen. There we go. Let's bring all these orbits off. And I'm going to back away from Saturn just a bit so that we can take a look, because these rings are actually organized, and they have these really great labels in here. So from inside out, they're labeled in yellow, D, in blue, C, and that's sort of orangey red. Let's switch to the other side. It's a little bit brighter. We have two different colors depending on how we use this in the dome. Okay, so that sort of orangey one is C. The sort of teal is actually a gap, and then that purpley pink is A. So we have D, C, B, A, and then F, which is very, very thin. Barely see it past that purpley one. And then we have another gap, and then we have E, that's the green one, and then G is even farther away. We don't have any colors for that because it's a very, very thin line. So you're probably thinking that makes no sense at all. How does that come about? The rings are labeled A through G based on the order of their discovery, which is sort of annoying. So the A ring was first in pink there, then the B ring in red, C is blue, D is yellow, and then the E ring was discovered after, then F and G, and it's not in order of their distance away. More on that in a moment. Okay, so let's take a look at the Cassini spacecraft in a very exciting portion of its journey at Saturn. This was on October 28th of 2015. You can see the Cassini spacecraft right there, and Saturn very close to it. This is arguably my favorite visual we've ever put together. You'll see Enceladus, which is a little tiny icy moon of Saturn in the background. And Enceladus is quite small. It's only about 313 miles in diameter. So that's like half the width of Texas. So quite small. And Enceladus is, again, this very icy little world. And on October 28th of 2015, this was not the first time that Enceladus flew by, or that Cassini flew by Enceladus, but this was the closest flyby. It got within about 28 miles above the South Pole. And you can see these weird sort of crack features that are called tiger stripes. And at the South Pole, there are actually these jets of water ice streaming out. And the Cassini spacecraft flew through them. So there are actually 100 different documented jets, and in this visual here, we have them all modeled to correct scale and location and orientation, and a nice representation of flow rate, which is about 200 kilograms per second for the whole system. These jets can spew out at about 800 miles per hour. This ice comes out at about 800 miles per hour. So this is pretty wild because, first off, let's back up. Enceladus, I'm going to play that for you one more time. Enceladus has water ice plumes, ice volcanoes, cryovolcanism. That's sort of funky and very exciting. And two, we flew through them with the spacecraft very close to the surface. So the spacecraft's instruments were actually able to sense these things, almost taste or smell the substance of these, and they determined that it is indeed water ice, and that this water ice does have hydrocarbons in it, and in particular, hydrocarbons that only form in the presence of, at least on the Earth, of sort of underwater vents that we see at the bottom of the ocean that have to be in at least 200 Fahrenheit water. So that's a very exciting thing. What this indicates about Enceladus is that it has an internal liquid water ocean, perhaps about 6 miles deep. The ocean is about 6 miles deep, and the icy crust before you get to that ocean is maybe, I don't know, 19 to 30 miles deep, something like thick, something like that. And then you get into that global underground, very cold, very salty, but still liquid water ocean. And also that there is this nice internal heat source, which is powering this active geology, these cryovolcanoes, and that it's a pretty substantial heat source. So if you have water, you have different hydrocarbons, and you have energy. These are the things that are needed for life. And so if you were looking for life somewhere else in the solar system, Enceladus is as good a place as any to look, and that's a super exciting thing. So I'm not telling you that there is life here, but if we were to look for life, which we are, this would be about as prime a spot to look as any, and it's super exciting. So I also want to bring you closer to Enceladus. We're gonna head there now, and what you may or may not notice, if we bring the rings back up, is that Enceladus is pretty smack dab in the middle of the E ring, and so that's sort of cool. So what's going on here? Well, the E ring, if we bring these colors off, is not something that we can just see sort of represented here. The E ring is very thin compared to the other rings, and it's the result of some interesting dynamics at work. And you can see those plumes of Enceladus there at the South Pole. And when we look at Enceladus, we see all these fissures and this cracking, and Enceladus is being acted upon by the different moons of Saturn and Saturn itself in what are called tidal forces, which is the same thing we experience on the Earth and the Moon, where the tides are pulled by interactions between the Earth and the Moon. Well, the same thing is happening here. So consider yourself, Enceladus, and consider the fellow sized moons as maybe your siblings, and perhaps Saturn as a parent, right? And when you get into something with your parents, sometimes maybe one of your parents says, hey, you should do this thing, and maybe a sibling says, you should do this other thing. And there's a bit of a tug of war going on there, and you sort of get stretched in different directions. And that's essentially what's happening in here. Saturn is pulling gravitationally on Enceladus. The other moons are pulling gravitationally on Enceladus, and there's a nice orbital resonance to these things with some of the moons. And the result of that is a lot of stretching and contracting, And this causes that cracking and those fissures, but also the interior, rocks are literally rubbing against each other and producing friction. And so if you were to rub your hands together very quickly, because of the friction between them, you would see that this produces heat, and that's the same thing that's going on inside of this moon. It's probably going on in other moons at Saturn as well. Certainly going on inside of moons of Jupiter, the big moons of Jupiter, Io in particular, which is the most volcanic place in the solar system. But this internal heat is enough to allow Enceladus to currently maintain this liquid water ocean, power these plumes, and then, as a result, these plumes sort of contribute to the E-ring. So some of this material falls back down gravitationally to the surface of Enceladus in the form of snow, but much of it gets sort of spewed out into space and then contributes to this spectacular ring. So you could say, this is my tough conversation for the night, you could say that Enceladus and Saturn were gravitationally attracted enough to put a ring on it, which is a terrible joke. And I'll stop while I'm ahead, or behind, whatever it is at this point. All right, so it's a lot harder too if I don't have an audience for you to laugh at me. Okay, so how big is this world? Let's take a look. Let's bring up the Earth and the Moon right next to, I think we're inside of the Earth, there we go. That's my mistake, always hurts to do that. So here's a comparison of Enceladus there in the middle. Ooh. Very delicate flying there. There is the Moon, there is the Earth, and you can see a nice comparison with Enceladus. And then let's actually jump back to Saturn and take a look at Saturn compared to the Moon as well, and also Earth. Okay, so I've been ignoring your questions simply because I don't have enough screens to look at all of them. Okay, someone said, can you do one planet each week? That would be awesome, including the Earth. That would be awesome. Maybe. We haven't picked all of the topics yet. We'll be talking about Hubble next week, so tune into that. But in the meantime, we are going to, you can go to Rocket Center .com/science never stops, or you can look on our Facebook at our previous videos, and we have very short planetary highlights, about 3-minute videos for all of the planets, plus the Moon, plus Pluto. So that's a shameless plug for that. You should go check it out. It's very cool. Let's see. Somebody says, how thin is the E-ring? Great question. And I guess on average, again, probably very, very thin, maybe even thinner than 30 feet. But I'm not entirely sure off the top of my head. Ooh, great question in here from James. You may have said this, but what is it about Saturn's gravity that creates these rings? Like, why does no other planet have rings? That's a great two-part question because, first off, other planets do have rings, actually. So both, or all of the gas giants actually do have rings. They're just not as prominent as Saturn's. The rings are the result of material that is trapped gravitationally by Saturn or any of the planets. And so what's exciting about this is that these rings, then you can see that when we were edge on, they were basically invisible. That these rings are at Saturn are likely the result of a moon that's strayed too close and crossed what's called the Roche limit. So basically this is a region where the gravitational pull of Saturn on said object is stronger than the forces that are holding that object together. So that area, that region, is different for different bodies. So you couldn't have the Earth that close to Saturn. It would get ripped apart, or something Earth-sized would get ripped apart. But you can have littler moons closer in than bigger moons. So a bigger moon could have strayed too close, maybe in the 100 million years ago, and these rings were the result of it getting ripped apart, and all its icy guts were sort of spewed around Saturn and then went into orbit around it and formed these very beautiful rings. Crazy. Okay, another question. Let's see. There is a question, is there a program on the web to explore this planet? The software we're using is called Digistar 6, which is what we use in our planetarium. It's not something that is freely accessible. You can go to worldwidetelescope.org to check that out, and you can take a look, although you can't fly through the rings there. You can go to the NASA Solar System sites, solarsystem.nasa.gov, and learn a lot more about Saturn and the various planets. For planets that we have good imagery of the terrain, you can go to NASA Treks, and those are really cool, and lots of fun things. Okay, cool. So there's another question: why is there a gap in the rings? And it is different, a different answer for different gaps. So we're going to take a look at the Anki Gap. So I'll bring down our size comparison, and this is this is a funky thing and something I'm very excited about. So we're going to head to a little tiny moon called Pan. And I think we may end up going sort of through Saturn. No, thankfully not. Okay, good. Okay, so we're heading on our way to a little tiny world named Pan, and this is in the Anki Gap. And this is a funky place because it's actually sort of UFO shaped. Kind of looks like a flying saucer in here. And no, it isn't a flying saucer, as best we can tell. But rather a very icy world. And this world is actually clearing its orbit gravitationally and sort of shepherding different little moonlets. Oop, we got too close and tried to land on it, sorry. That's why the orientation flicked up like that. It's sort of shepherding little moonlets around with it and clearing out this path in here. And you can actually see waves in the rings, if we look sort of right in here, and these are due to gravitational interactions between Pan and these ring particles. I should point out that the ring particles are quite literally particles smaller than you can see, all the way up to the occasional mountain, like a boulder bigger than your house. But again, on average, quite thin. So yeah, so the reason that this funky world is sort of saucer-shaped is because in the plane of the rings in here, you can see that this is where the ice is accumulating whenever something does get in its way and isn't sort of gravitationally removed. It sticks into it and sort of sucks in. So this is this nice sort of like porous ring around it. And then the rest is sort of a weird rocky material. So if we zoom away, you can get a sense of where that's situated in the rings, and pretty wild, definitely. Okay, so backing away. So there was a question about Titan, and I would like to show you Titan before we wrap up, because it is a very unique world. It's a very big moon, like I said before, and I didn't prepare for this, so I actually don't know. I don't recall which map of Titan we have set up, so this will be interesting for both of us here. As we zoom into Titan, Titan has this sort of yellowish haze to it, and it's the only moon in our entire solar system that has an atmosphere at all. And interestingly, its atmosphere is actually thicker than the Earth's by about 50%. So it's about 1.5 times the atmospheric pressure of the Earth. And this atmosphere is fairly stable. It does not cause much warmth for this world, which may be a little bit counterintuitive if you're sort of thinking about how our atmosphere acts as a blanket and Venus's does as well. It does act as a blanket, but because we're so far away from the sun, about 10 times the distance that the Earth is from the sun. So we're looking at about 9.5 astronomical units, where 1 AU is the average distance from the Earth to the sun, and that's about 93 million miles. So you're looking at almost a billion miles that Saturn and its moons are away from the sun on average. Anyway, so the point is it's very cold. And despite being very cold, it still has some very interesting things going on. You can see these sort of darker areas that look almost like water systems, like lakes or something on the Earth, and they are, which is so strange and also so cool because it's freezing there. These are methane lakes. So just like the Earth has a water cycle, Titan has a methane cycle. So it snows methane. It rains methane. There are methane clouds. There is liquid methane in lakes and rivers on the surface. Very strange place. So Titan is also an interesting world in that it does have this, stable atmosphere that isn't crushing. It does have its own liquid cycle, just a different liquid, and it does have an internal heat source. It probably has its own interior ocean, whether it's liquid water or methane or a combination of them, maybe different levels of different things. So that is all very funky, and it also is a fairly prime place to look for life as a result. It is a very unique location in the solar system, similar to Enceladus, but unique in different ways. And it is a place that we have landed on with the Huygens probe that was brought by the Cassini spacecraft, and you can take a look at landing videos on the internet for that. Those are, excuse me, super cool. And coffee at 7:30 at night to keep awake. And anyway, so it's a funky place. Very cool footage of the surface. Unfortunately, the Huygens probe broke shortly after it touched down, and we didn't get tons of imagery, but what we did get was very exciting, very neat. All right. Let me back up just a little bit more, and I'll bring up a size comparison one more time so you can get an idea of a comparison to the Earth and the Moon. There you go. So it's a little bit bigger than the Moon, and a little bit smaller than the Earth, and beautiful and strange nonetheless. All right, so I think I've covered probably most of the things that I was hoping to cover at this point. Hopefully I've highlighted that Saturn is a very interesting system. It's a place that is very unique for a lot of reasons. It's almost its own solar system, so to speak, because of these very many moons. And it's a world that we certainly want to spend more, we want to send more spacecraft to in the near future, just because there's so much to learn, both at Saturn, but also with all of these 82 moons. We have explored them in some detail, but we have so much more to explore, so many more to explore. We need dedicated spacecraft to go to Titan, to go to Enceladus, to go to places like Mimas and Phoebe and Pan and all of these fun places. So lots more to come in the future. And there is a mission called Dragonfly, which is launching, I think, in 2022, hopefully, which is sort of an octocopter, basically a drone that's going to go to Titan and fly around. And that's going to be absolutely awesome. So super stoked about that. And stay tuned for more info on that as that sort of continues to be awesome. But on that note, I think my time is up and I need to catch up on some sleep before my daughter is awake all night. So if you have any other questions, post them in the comments. If you're just tuning in, you can watch the recap of this, which we'll post as soon as we wrap it up. And I'll be moderating the questions tonight, giving you some answers if there's anything that I didn't get to mention tonight. So thank you so much for joining me. Hope that you enjoyed it. Remember that this is Science Never Stops. Science never stops, not at the U.S. Space and Rocket Center or anywhere else. And my name is David Weigel, and I hope you have a great evening. Take care.